Hello and welcome. Chapter 21, Surface Area, Volume and Capacity, and we'll discuss the surface area, volume and capacity of cuboid, cube and cylinder. There are two ways that we can measure the size of a 3D object or a solid, and those are surface area and volume. Surface area is the measure of total area of surfaces that make up the solid. What is volume? Volume of a solid is the total space occupied by an object. We need three dimensions to express the volume, and those dimensions are length, breadth, and depth or height. Here, this is a cuboid and there are three dimensions. The first dimension is the length L, and second one is the dimensions breadth B, and this dimension is at an angle of 90 degree to the direction of the length, and the third dimension is the height or depth, and this height is perpendicular to both the direction of length and direction of the breadth. So this angle is 98 degree, this angle is also 90 degree. So this direction height is perpendicular to the plane of the length and breadth. Volume is measured by the number of unit cubes required to make the solid. In one of my previous videos, I have explained the concept of a unit square while measuring the area of a 2D shape. In case of a solid or 3D shape, the concept of unit cube is applicable. Now, what is a cube? A cube is a special cuboid, and a cuboid is a special prism. A cuboid is a rectangular prism. A cube is a 3D figure having three mutually perpendicular dimensions of equal lengths. Let us understand a cube now. This is a cube and this is the length of the cube. This is the breadth of the cube and this is the height of the cube. So the volume of the cube is equal to length multiplied by breadth multiplied by height of the cube. Now a cube is a special prism having 6 square shaped faces, and these are the faces. Suppose this is the top face of the cube and this is the front face of the cube and this is the side face of the cube. If you look from the top, then this is the top view and that is why I am calling it the top face. And if you look from the front side, then this is the front view and that is why it is front face. And if you look from the right side, then this is the right side face of the cube. Similarly, there is left side face, there is bottom face, and there is one more face that is behind the front face, and total there are 6 faces. So this is face 1, this is face number 2, this is face number 3. Similarly, bottom face will be face number 4, left side face is face number 5, and behind face is face number 6. So there are total 6 faces, and in a cube all these 6 faces are square shaped faces. So the faces are square faces and all faces are equal. Also, each edge of a cube is of equal length. See, these are the edges of the cube. Similarly, this is another edge and this is also an edge and this is also an edge. In one of my previous videos, I have mentioned about the vertices, edges and faces, and also about the Euler's formula, which gives you the relation between edges, faces and number of vertices. And if Its edges are of equal length. Suppose this length are A. Therefore, B is equal to A, L is also equal to A, and H is also equal to A. So the volume is equal to L multiplied by B. So all are equal to A, and the volume become A cube cubic unit. And this unit may be millimeter, it may be centimeter, it may be meter, it may be kilometer, and so on. And accordingly, it will be called cubic centimeter, cubic millimeter, cubic meter, etc. There is another concept of unit cube. So what is a unit cube? In this cube, each edge of the cube is of equal length, and that we have assumed to be equal to A. Now, if A is equal to 1 unit of length, volume will be equal to A cube equal to 1 cube, and that is equal to 1 cubic unit. And this type of cube is called the unit cube. Now let us understand more about unit cube. Now the concept of unit cube. This is a cube, and you can imagine this cube to be made up of many small cubes. And if each small cube is a unit cube, then you can say that this whole cube is made up of some unit cubes. So volume is measured by the number of unit cubes required to make the solid. You can consider any cube, say this is the cube, and if the length L is equal to 1 and breadth is also equal to 1 and height is also 1, then the volume of this cube is equal to 1 multiplied by 1 multiplied by 1 is equal to 1 cubic unit. So there are actually 27 such cubes, and each cube is of 1 cubic unit. So what will be the total volume of the bigger cube? That will be equal to actually 1 plus 1 plus 1 plus 1, etc. So if there are 27 cubes, then it will be 27 cubic units, the volume of the bigger cube. So this is the idea that volume is measured by the number of unit cubes required to make the solid. So in this case, these 27 unit cubes make the whole cube, and that is why the volume of the bigger cube is equal to 27 cubic units. You can understand with this example, and this is the length side, and this is the breadth side, and this is the height. So 1, 2 and 3, there are 3 cubes along the length. Similarly 1, 2 and 3 cubes along the breadth, and 1, 2 and 3 cubes along the height, and each cube is of 1 cubic unit, and there are 27 such cubes. So if we consider this, that 3 unit multiplied by 3 unit multiplied by 3 unit length, breadth and height, it becomes 27 cubic units, the total volume of the whole cube. Surface area of a cuboid and cube. This is a cuboid, and so what is surface area? Surface area is the sum of areas of all the faces of an object or a 3D object. Here in this cuboid, there are 6 faces, and opposite faces are equal, and their dimensions are length AB, breadth BC, and height AE. And you can see that bottom face ABCD is congruent or equal to the top face EFGH. So their areas are also equal. Similarly, left face is congruent to the right face, and front face is congruent to the back face. Total area of the bottom face and the top face is equal to 2 times. So if we take the bottom face, length is equal to L, that is equal to AB multiplied by breadth is equal to B. And now we'll take the front face ABFE and DCGH. So areas of front and back faces are equal to 2 times the area of one of the faces, say ABFE, then the dimensions are L multiplied by H. Now we'll take the left face and the right face, and they are also congruent. So areas of left and right faces are 2 times one of the faces, say the left face ADHE, and their dimensions are B multiplied by height H. So now we can find the total surface area is equal to, you can add them up, 2 is common, L into B plus L into H plus B into H square units. So this is the total surface area of the cuboid. Now if this is a cube, then all the 3 dimensions are equal. That means all the edges are of equal length, and in that case L is equal to B is equal to H, and suppose the lengths are equal to A, all the edges of the cube. So total surface area is equal to 2 multiplied by L multiplied by B is equal to A into A plus L multiplied by H is also equal to A multiplied by A, and plus BH is also A multiplied by A. So this is equal to twice A square plus A square plus A square, and this is equal to 2 multiplied by, there are 3 A squares, so this is 3A square, and that is equal to 6A square, and this is square units. Total surface area of a cube having the length of the edge equal to A. Capacity of a container. This is a container, and it can contains or it can accommodate some material inside the container, and the material may be solid, liquid or gaseous. There is some thickness of the container. So the outer volume of the container is more than the inner volume of the container. And whenever we consider the capacity of the container, then we have to consider the inner volume of the container. And what is the definition of the capacity of the container? It is the internal volume of the container. For example, you know that pressure cookers comes in different sizes like 3 liters, 4 liters, 5 liters, etc. And this indicates the internal capacity or internal volume of the container. The outside volume may be more than the internal volume or the capacity of the container. And in case of an engine of a car or bike, this is the cylinder of the engine. There is written something like 150 cc, 250 cc, etc. And these are actually the capacity of the cylinder, how much air and fuel it can accommodate inside the cylinder. That is the capacity of the cylinder, and accordingly in the specification of the engines this capacity is written. If the capacity or cc means cubic centimeter, if the cc is more, then the power of the engine is also more. Now in case of a car also the capacity is written like 1 liter, 1.2 liter, 1.5 liter, etc. And these are also the cubic capacity or cubic centimeter of the cylinder of the engine. 1 liter is equal to 1000 cc, and generally in a car there are 4 cylinders, and each cylinder is of capacity 250 cc, and the total capacity become 1000 cc. So in case of a 1.2 liter or 1200 cc car, it is the capacity of the each cylinder is 300 cc. So this is about the capacity of a container. So thank you. In the next video we'll solve all the problems of exercise 21A.